Hello everyone, welcome to my channel. Now today we are starting with the third part of the chapter Gravitation. This is the last and final part. So in this video we are going to study about the mass, weight, earth gravitational potential energy, and the last topic will be escape velocity. Now let's just get started with this video. The first topic that we are going to study is the mass. Now the mass, you must have heard before also that mass is the amount of matter present in the body. Okay, for example, if an adult human body contains 4 to 6 liters of blood, right, then if you just traveled on the moon, Jupiter or other planets, the amount of blood will remain the same, right? The amount of blood will not change. That means on the earth it will be 4 to 6 liters, on the moon it will also be 4 to 6 liters, and on the Jupiter planet also it will be 4 to 6 liters. So you can say that mass is something that does not change when you change your place from one planet to the another planet or to any other places, right? When you weigh your weight on the weighing machine, it shows you around 30 kg, 50 kg, 60 kg. So what is that? 50 kg, 60 kg is the mass of the matter present in your body. That is nothing but the flesh and blood, right? Now, so you can say that the SI unit of the mass is kilogram. Whenever you measure the mass, it is nothing but the kilogram. But in United States and other many foreign countries, the mass is measured by a unit that is called as pounds. Okay. Now, mass is called as a scalar quantity. Mass is called as a scalar quantity. What is a scalar quantity? Scalar quantity basically a numerical content, or you can say scalar quantity is just a number or a magnitude that is a real number, right? For example, distance. Okay, whenever you say that you have to go to that place, you say it is 2 kilometers from here, right? It is 5 kilometers from this place. So that is nothing but a numerical value, right? So a distance, mass, it is a scalar quantity. It only gives you about the numbers. Okay, it gives you information about the numbers. That is also a real number, right? And there is also other quantity which is called as vector quantity. The vector quantity gives you numerical content, that is number in real numbers, and also gives you the direction. Okay, for example, if you remember about the displacement is nothing but the distance or shortest distance between the 2 points. Okay, but displacement is also having a direction. It shows you direction, go left, go right, go straight, then you will reach your destination, right? So displacement can be called as a vector quantity, and mass here can be called as a scalar quantity. So whenever you measure your weight or on a weighing machine, it shows you 50-60 kilogram. That is nothing but just a real number. Okay, so that can be called as a scalar quantity. Now mass is independent of the acceleration due to gravity. Now as I told you that if you are on the earth or you go to moon or Jupiter, the amount of content present in your body will not change. Okay, the amount of content present in your body will not change. Okay, so if you have same liter of blood on the earth, like 4 to 6 liters of blood, so when you move to moon or Jupiter, so at that time also the amount of blood in your body will remain the same, or you can say it will always remain same. It has no relation with the gravitational force. Okay, now so the value of mass is same everywhere, you can say that. Also, mass is a measure of inertia of an object. Now what is an inertia? Inertia is very simple to understand. Let us consider if you have a one small ball, okay, or you can say a ball, and another thing is a wall you have in your house. Okay, now you can move the ball very easily because it is very light according to you, but you cannot move the walls of your home, right? because we are not that capable to move the walls of your home. So you can say that the ball is having a less inertia as compared to walls, because walls are too strong for the humans to break it. Okay, and balls are lighter in weight, so you can move that very easily. So basically inertia is a resistance. So a ball has less resistance, you can move it very easily with a small force, but a wall has a more resistance and you cannot move or break the wall, right? So you can say that a ball is having a less inertia and a wall has a more inertia. So mass is the measure of inertia. So if the inertia is higher, you can say that the mass of that object is also higher. Okay, because if the mass is higher, you cannot move that object alone. Now the next is we are going to study is the weight. What is a weight? Weight is basically the force exerted by the earth on its object. Okay, so weight of an object is defined as the force with which the earth attracts the object. So you know that each and every object is attracted by the earth towards its center. So weight is nothing but that force which attracts the object towards itself. So here if you consider F is the force, M is the mass of an object, then the weight is equal to F is equal to M into G. Okay, F is equal to M into G, where M is the mass of the object and G is the acceleration due to gravity. Okay, so you got it, that weight is of an object is defined as the force with which the earth attracts the object. Okay, also you got the formula for weight, that is F is equal to M into G. Okay, now if you are having your mass as 40 kg and you know that this is the acceleration due to gravity, acceleration due to gravity on the earth is 9.8, or you can take it as 10. So you multiply 40 with 10, so you will get 400, right? You will get 400, which is nothing but the weight of your body on the earth. Now weight is nothing but measured in newtons. Okay, so if you multiply your 40 kg mass with the G, that is 10, so 40 into 10 will give you 400 newtons, and 400 newtons is nothing but the weight of your body on the earth. Okay, also force is a vector quantity, as just I have told you before that we have two quantities, scalar quantity and vector quantity. Scalar quantity is having only a numerical value, but a vector quantity having both numerical value as well as the direction. So here force is a vector quantity, force is a vector quantity. And also you know that if you are on the surface of the earth, your weight or the force is directed towards the center of the earth. This picture you must have seen in the last video, that we are on the surface of the earth and our force of attraction is directed towards the center of the earth. So basically this is the direction, this is the direction which is getting to the center of the earth. And also we have a numerical value, so basically it has got both direction as well as the magnitude, that is nothing but numerical value. So if you have numerical value as well as direction, then you can say that quantity is a vector quantity. Okay, so here force is a vector quantity and its direction is towards the center of the earth. Okay, I hope you got this weight. Now also the weight of an object changes from place to place. Why it changes from place to place? Now as you can say in the formula of weight, it is nothing but mass into gravity. Okay, that is nothing but acceleration due to gravity. Now you know that in the entire universe every planet, stars have their own gravity. Okay, so if you are on earth, we have calculated the gravity as 9.77, which is rounded off to 9.8, right? Now if you go to moon or any other planet, the value of G changes. Okay, value of G changes here because the gravity is different for different planets. So the value of G will change, and if the value of G will change, then your weight will also change. Okay, So the weight of an object changes from place to place. Okay, now we will compare both mass and weight. So this is the table I have created. You can just note it down. This is the difference between mass and weight, mostly coming in the exams, okay, for 2 to 3 marks. So I've written here both the definition in the first column. Mass is the amount of matter present in the body, and here weight of an object is defined as the force with which the earth attracts the object. This is both the definitions. Here the SI unit is kilogram and here SI unit is Newton. Here mass is a scalar quantity and weight is a vector quantity. Mass is same everywhere and weight varies from place to place. Why? As g varies. Okay, varies means changes. Here mass cannot be zero. Okay, mass cannot be zero, but weight can be zero if no gravity acts on the object. So as you know that in the formula of weight, here F is equal to m into g. If you happen to move from the earth at an infinite distance, okay, at an infinite distance, then the value of g will become 0, and if the value of g becomes 0, then 0 into m will give you 0, and the weight, that is nothing but force, will become 0. Even though you have mass, but the weight will become 0 because the g will become 0, right? So you can say that weight can be 0 but mass cannot be 0. Okay, we will study next topic is buoyant force plus gravitational force. Buoyant force plus gravitational force. The both terms we are going to study in the same clips here. I have created a small video here. So basically this is a ground. This is the ground and we have a building here. Okay, and you are standing on the top of the building. You are standing on the top of the building. Now you have three objects: a feather, right, which is lightest in weight, and the next is you have a pencil which is heavier as compared to your feather, and next is your stone. Okay, stone is heavier than pencil. So you have three objects: feather, pencil and a stone. Now if you are standing on the top of your building, okay, if you are standing on the top of your building and you throw one by one, okay, so what happens is here your feather, okay, your feather will come slowly to the ground. Your feather will come slowly to the ground. Why it will come slowly? Because the feather will float into the air due to its lighter weight and it will come slowly to the ground. Okay, now on the feather, there are two forces acting on the feather. Now the air was trying to push feather upward, but due to the weight of the feather it came slowly downwards. Okay, it came downward very slowly. Second thing, when you throw the feather from the top of the building, the earth started attracting towards itself. Earth started attracting towards itself. That is two forces acting on the feather. First, that is nothing but the force applied by the air. Force applied by the air when it was floating in the air. And second force is the gravitational force. Now the next object that you throw here is the pencil. Okay, now pencil is heavy as compared to feather, so pencil will come down to the earth fast as compared to feather. Okay, so why? Because the weight of the pencil is heavier as compared to feather. So here the air will try to stop, or you can say that pencil should float in the air, but it will not flow because of the weight of the pencil. Okay, also the gravitational force on this pencil, okay, is greater as compared to the gravitational force on the feather. Okay, so it will fall down very fast. And the next thing here is nothing but the stone. Okay, is nothing but the stone. Now stone has a heavier weight as compared to pencil and a feather. The stone will directly hit the ground due to the heavier weight as compared to pencil and a feather. So the gravitational force acting on the stone is greater than the pencil and also greater than the feather. So the gravitational force on the stone was greater. Also, due to the heavier weight, the air was not able to stop it from falling. Okay, so here in this case we come across two forces. First force is the force applied by the air on the three objects, okay, that were preventing to fall on the earth. And second is the gravitational force. This force is attracting each and every object on the earth, you know that. Okay, so gravitational force will be acting on all the three objects, but the second force, that is nothing but a buoyant force. So basically buoyant force is the force applied by the air. Buoyant force is the force applied by the air which is protecting the objects from falling towards the earth. Okay, so here two forces come into the picture: buoyant force, which is due to the air, and second is the gravitational force. Now the next that we are going to see one more example, which is nothing but if you happen to fall from a height of a building, what happens there, that due to your heavier weight, you fall directly on the ground, and the force you feel by the air is very less. Okay, so the gravitational force acting on your body is greater than the force applied by the air on your body. So here also two forces comes into the picture: buoyant force and the gravitational force. But the buoyant force is less due to your heavier weight, and second thing, gravitational force is more due to your heavier weight. Okay, so the now next we are going to study is the free fall. What is a free fall? As now we have explained that whenever you throw anything from a particular height, two forces comes into picture. First is the gravitational force and second is the buoyant force. Okay, now what is a free fall? Free fall means that you throw any object from a height, but only a force of gravity alone acts on the objects and not the buoyant force. Okay, so once again I like to repeat: whenever you throw any object from a particular height, on that object there should be only force of gravity acting on it and not the buoyant forces. Okay, now buoyant forces can be eliminated, okay, or you can say it can be removed if you take out all the air present in the space, okay, present in our space. But this is only possible in vacuum. If you know that in vacuum there is no air, it is just like in the universe or outside the earth. If you go outside the earth, there is no air, right? So basically that is nothing but a vacuum. So in the case of vacuum, there is no air. So if there will be no air, there will be no buoyant forces, and the only force which will act on the object is nothing but the gravitational force. Okay, so the free fall can be defined as whenever an object moves under the influence of the force of gravity alone, it is said to be falling freely. Okay, so whenever you throw any object from a height, there should be only one force acting on the body, which is nothing but the force of gravity and not the buoyant forces. Now as you know that we have always two forces whenever you throw from a height, that is buoyant force due to the air and gravitational force. So buoyant force can be eliminated if you remove all the air present in your environment. Okay, so when the object is released from a particular height, object experiences buoyant force. As I have already explained you that whenever you throw any object from a particular height, it will experience buoyant force. Why it will experience? Due to air. Okay, so here you can see another example of buoyant force. This is a buoyant force. here acting by the water on the ball. As you know that whenever you throw a ball on the water, the ball does not get inside the water, it floats on the water. Okay, just like this, it is half dipped and half it is outside, right? So here the water is not allowing the ball to dip into it, okay, due to the air. So here the water is applying a buoyant force on the ball so that it does not get inside the water. Okay, this is just a simple example for the buoyant force. Now I'll show you one simple example of a vacuum where you can see that a free fall is possible only in vacuum. Free fall is possible only in vacuum, and in vacuum there is no air. If there is no air, there is no buoyant forces. Okay, now this is the vacuum. Now in vacuum there is no air here. Okay, this is a sphere and this is a feather. Okay, the feather is lightest and sphere is heavy, okay, in weight. So here you can say that we have two objects. First is a sphere, second one is a feather. Both are attached at a particular height, and this space is a vacuum. Okay, so there is no air, right? So we will see the clip what happens here. The string will be released. See now. So they are dropped. Now whenever they are dropped, you can see that the sphere and the feather both are together. Okay, and once they fall and hit the box at the same time, you can see that feather and the ball both are hitting here. This is the box here kept. So both are hitting the box at the same time. Now why they are hitting the boxes at the same time? Because there is no air. Now if there is no air, there is no buoyant forces. Now if you have seen in the previous video, there was a feather which was floating in the air and then it hit the ground. And there was this stone which was heavier and it came directly to the ground. So here in vacuum the air is not present, so feather came directly on the table here, and also the sphere is heavier, so that also came directly due to the absence of air, or you can say absence of buoyant forces. It will hit the table at the same time. You can see here. See, so the true free fall is possible only in vacuum. True free fall is possible only in vacuum, because in vacuum there is no air, which makes no buoyant forces. Okay, now the next thing that we are going to study is the equations. Okay, is the equations. Now as you know that for a freely falling body or an object, the velocity on reaching the earth and the time taken for it can be calculated using Newton's law of motion. Now as you know, Newton's law of motion, we have 3 Newton's law of motion, but before going to that, come to that video. So as you can see from this video, initially both the spheres and the feather were attached to a string at a particular height from the ground. Initially there was no velocity, that means initial velocity, which is taken as u. Here in this case, the initial velocity of both the objects will become 0. Initial velocity of both these objects will become 0. Now once they travel downward, okay, and they strike the ground, okay, so they are traveling here with the velocity v. Okay, they are traveling with the velocity of v, but here the initial velocity will become 0 because initially they were tied to the string, so the initial velocity was 0. There will exist a final velocity which is v. Okay, the next thing is the acceleration due to gravity. Now when the object is released from a particular height, it will attracted by the earth. Now whenever it will attract by the earth, the force of gravity acts on both of them. Okay, now force of gravity is taken as g. So We know the Newton's three laws of motion, three equations we have. Okay, that is V is equal to U plus AT, S is equal to UT plus half AT square, V square is equal to U square plus 2AS. But here V will exist and U will become 0, and here the acceleration A will become as G. So we will substitute U as 0 and A as G. So we get this equations. Here V is equal to gt, S is equal to half gt square, and V square is equal to 2gs. This is the Newton's equations of motion in the case of freely falling object. Okay, so the next that we are going to study is about the kinetic energy and potential energy. Now you must have studied about the kinetic energy and potential energy. I will define definitions for you. What is a potential energy? Potential energy is the energy stored by an object due to its position. And what is a kinetic energy? Kinetic energy is the energy processed by the object due to its motion. Now if you see here that we have a slope. Okay, this is just a slope here, and we have a ball. Okay, now the ball travels upward. Okay, the ball travels upward and it stops on the top. Now when it stops on the top, due to its position, it will possess energy which is called as a potential energy. Now once it flows down, so due to its motion, it will have another type of energy that is called as a kinetic energy. So whenever the ball is in motion, that is it is moving, you can say that it has a kinetic energy. When a ball is at one position, the ball is just at one position doing no motions, then you can say that ball is having a potential energy. Okay, for example, if you are sitting one place, okay, if you are sitting at one place for 1 hour, then that time the energy processed by your body will be a potential energy. And when you walk some distance, and that time the energy processed by your body will be the kinetic energy. So when an object does motion, it is nothing but a kinetic energy. When the object is just at one position and doing no motion, then that time we call this as a potential energy. Okay, so I hope you got this potential energy as a kinetic energy. Now we will study about the gravitational potential energy here. Okay, because we are all body which is on the surface of the earth. As you know that every body in the universe, that is planets, stars, they all have a gravity. Our earth has also a gravity, right, which is having a acceleration as 9.77 meter per second square. Okay, now as there are many objects which is present on the earth, all are attracted by the earth towards itself, towards the center of the earth. So even we objects, that is human beings, trees, animals, vehicles, all are having potential energy as well as kinetic energy at different time. Okay, so here we are studying about the gravitational potential energy. First of all, what is a potential energy? The energy stored in an object because of its position or state is known as a potential energy. Basically, potential energy is nothing but the energy can be defined as a force or a displacement. Okay, force into displacement, and we have already learned that potential energy is given by m into g into h. M is the mass, g is the acceleration due to gravity, and h is the change of height. Okay, now if you see in this picture, there are two skier. Okay, now initially they are both standing at one position. Okay, so whenever they are standing at one position, it can be said that both bodies are having a potential energy. But when they start their movement going from upward to downward, then that time their body will possess another type of energy which is nothing but a kinetic energy. Also you can see from this formula that The formula is nothing but the m into g into h. Now here we have two people. The green is having a higher weight as compared to the yellow one. Okay, for let's just say this is 30 kg, this person is a 30 kg and this person is a 50 kg. So when you apply the mass of this person into this formula, the mass is 50. Okay, g is nothing but you can take it as 10, height you can take as any value, this is 50 meter or 100 meter. So in the case of green one, due to its heavy mass, you can say that the potential energy gained by this body will be greater as compared to the potential energy gained by this person. Okay, so the green person will be having greater potential energy due to its mass as compared to the yellow one. Okay, right? Also, the gravitational potential energy here is given by minus gmm upon r plus h. Minus gmm upon r plus h. Now, why it is minus? Since the body is moving towards the earth, therefore, here the acceleration due to gravity will be minus of g. Okay, so here it is minus. So the formula here becomes g m upon r plus h. Okay, r is the radius of the earth, h is the distance from the surface of the earth. Okay, also capital M is the mass of the earth. Okay, mass of the earth, you know, 6 into 10 to the power 24 kg, and small m is the mass of the body. Okay, for consider v objects, we can consider our masses, also any other object present on the surface of the earth. Okay, now the GPE on object at infinite distance will be 0. Okay, why it happens to be 0? As you know that the force of gravity decreases when we move away from the earth. Okay, when we move away from the earth, so the force of gravity decreases when we move away from the earth. So here the value of g will decrease. If the value of g will decrease, so that the gravitational potential energy will also decrease. Okay, and when you go to the infinite distance away from the earth, the value of g will become 0, and so does the gravitational potential energy will also become 0. Okay, now the next thing that we are going to study is the escape velocity, which is the last topic for this video and also for the chapter. Right, now first of all, let us consider that you are having a ball. Okay, and you are throwing towards the sky. Okay, you are having a ball and you are throwing towards the sky. It goes to a particular height. Okay, and then it again falls back to the earth. So basically this height is the maximum height. This height is the maximum height achieved by a ball, and then it falls back to the earth. It falls back to the earth because of the gravitational force. Okay, but the maximum height is this height. Okay, right? Now if you think that if you increase the velocity while throwing a ball, if you increase the velocity while throwing a ball, the ball will achieve more height. Okay, and then it will come back to the earth. So if you throw a ball with the higher velocity, the higher height reached by the ball. Okay, you can try this. The next thing, we are going to calculate the maximum height that is going to travel by the ball when you throw a ball. Okay, now consider Newton's third law of motion, which is nothing but the v square is equal to u square plus 2as. Okay, now while throwing a ball, the initial velocity is not 0 here. The initial velocity will be u. Okay, the initial velocity will be u, but when you throw the ball and it comes back to the earth, when it comes back to the earth, the final velocity here becomes 0. The final velocity will become 0. Second thing, the force acting on the ball is nothing but the force of gravity, right? and the ball is hitting the ground, that means it is traveling towards the earth. Now when it's traveling towards the earth, we take acceleration due to gravity as g, and it is traveling towards the earth, we take that as minus. I have told you before also that ball is hitting the ground, that means it is traveling towards the earth, so at that time we take acceleration as minus of g. When the ball going away from the surface of the earth, when the ball is going away from the surface of the earth, we take acceleration due to gravity as plus g. Okay, so in this equation we will substitute final velocity as 0 because it will hit the ground and velocity will become 0, and acceleration due to gravity as minus of g. So we substituted v is 0 and a as minus of g. Now this minus term will come over here as plus, so we will get 2sg is equal to u square, and then the s value will nothing but the u square upon 2g. S is equal to u square upon 2g. Basically s is nothing but the height reached by a ball. We get u square upon 2g. Now what is a u? U is the initial velocity upon 2g. G is nothing but the gravity. Now if you move anywhere on the earth, the gravity will not change, but if you change the velocity, that is initial velocity u, then the maximum height can be greater. Suppose you throw a ball at 20 km per hour. Okay, so here we will substitute 20 square upon 2 into g. We take g as 10 for round off. You will get a maximum height reached by a ball. Okay, and then you throw another ball at a speed of 40 km per hour. Then here it will become 40 square upon 2 into 10. Okay, obviously the maximum height reached by the ball at 40 km per hour will be greater as compared to the height reached by the ball which was traveling at a 20 km per hour. Okay, so whenever you throw a ball at a higher velocity, the ball will achieve maximum height. Okay, if you throw a ball with a low velocity, then the height achieved by the ball will also be less. Okay, now if we increase the initial velocity, then the height reached by the ball also increases. We have studied this. Thus higher the initial velocity can make the ball overcome the gravity and will not come back. Okay, so if you consider that you thrown a ball, okay, at a very high velocity, so that it can escape the earth gravitational. Basically this is a field of gravitational, okay, field of gravitation of earth, and if your ball travels outside the field of gravitation, then that ball will not come back to the earth. Okay, then that ball will not come back to the earth. Okay, if you want that the ball should not come back, so the maximum velocity is required as 11.2 km per second. 11.2 km per second. If you want to send the spacecraft on the moon, then the spacecraft should be traveling equal to or greater than 11.2 km per second. Then it will escape the earth's gravitational field and it will travel to the moon. Okay, so if you want your ball that should not come back to the earth, then you have to throw your ball at a speed of 11.2 km per second. Okay, so this velocity is called as a escape velocity, because at this velocity will help you to escape the earth gravitational field. Okay, that's why it is called as a escape velocity. Okay, now we will see how 11.2 km per second is calculated. So first of all, definition: escape velocity is the minimum speed needed for free object to escape from the gravitational influence. Influence means field. Okay, So escape velocity is the minimum speed needed for free object to escape from the gravitational influence. This is the definition. Now we will calculate the escape velocity. What is the value of escape velocity? How we got 11.2 kilometer per second? Okay. Now consider you have object one on the surface of the earth and one at an infinite distance from the earth. Okay. So we have the object at two different positions, one on the surface of the earth and another at the infinite distance from the earth. If you are on the surface of the earth, and that time the kinetic energy will be half mv square. Okay, here v is nothing but the escape velocity, because at that time you will be throwing your object towards the sky, so that velocity will be escape velocity. Okay, potential energy we have already known that it is nothing but minus gmm upon r. Okay, we have already seen that in the gravitational potential energy. So the total energy will be kinetic plus potential, that is half mv square. Here it is minus, plus minus will become minus, then gmm upon r. So basically this is the total energy of the object present on the surface of the moon. Now for the object present at an infinite distance from the earth. Okay, now you know that if you throw any object on from the earth and it will go in the space, the object will not do any motion in the space. Okay, object will not do any motion in the space, so that time the velocity will become zero. That time the velocity will become zero. So in this formula v will become zero, v into m into half will become zero. So the kinetic energy at that time will become zero due to its no motion. Okay, next thing is the potential energy. As you know, the potential energy formula is minus gmm upon r. Now since it is at an infinite distance from the surface of the earth, so here the value of r will become infinite. Here the value of r will become infinite, and any number upon infinite will give you zero. Any number upon infinite will give you zero. So here the kinetic energy is also zero, potential energy is also zero, so the total energy will become 0 plus 0, which is nothing but 0. So as you know, on the surface of the earth this is the total energy, and at an infinite distance from the earth this is the total energy. Now as you know from the law of conservation of energy, energy can neither be created nor be destroyed, but it can be transferred from one form to the another. Okay, that means this both the energies are nothing but equal. Okay, from the principle of conservation of energy. So E1 is equal to E2. This is the total energy E1, this is the total energy E2. Both are equal from the principle of conservation of energy, because energy cannot be destroyed. So that means it is converted from this form to this form. Okay, so we have equated them. This minus will come over here as plus. Okay, and 2 will get multiplied here, that is nothing but 2 gmm upon r, and next thing the mmm will get common, or you can say cancelled. So we left with half v square minus gm upon r. So v square is equal to 2 gm upon r. V square is equal to 2 gm upon r. Then square will get here as a under root square root 2 gm upon r. Now if you calculate the value of gm upon r, we know the value of g, that is nothing but 6.673 into 10 to the power minus 11. Mass is nothing but 6 into 10 to the power 24 upon r, which is 6.4 into 10 to the power 6 kilometer. So when you substitute all this value, you get here as the value as 11.2 kilometer per second. Okay, so the spacecraft which are sent to the moon or any other planet will have the initial velocity greater than the escape velocity, so that they overcome the earth's gravitational attraction and can travel to these objects. Okay, so whenever we send the spacecraft to another planets or in the universe, the initial velocity should be greater than 11.2 kilometer per second, so they can easily escape or penetrate the earth's gravitational field and travel to their planets. Okay. Now in the case of satellite, the satellites, you know that it is revolving around our earth. Okay. So in the case of satellite, the initial velocity is not the escape velocity. Okay, it is less than the escape velocity. That means their velocity will be less than 11.2 kilometer per second. So if their initial velocity will be less than 11.2 kilometer per second, then they will be in the field of Earth's gravitational, and it will rotate around the Earth. Okay, so here I have shown you how we calculate the escape velocity and what is the escape velocity. With this diagram you can easily understand that whenever you throw an object from the Earth and it escape the gravitational field of the Earth, this is the gravitational field of the Earth. Okay, so if it escape the gravitational field of the Earth, then we say that the ball is thrown at a escape velocity, and then escape velocity is nothing but the 11.2 kilometer per second. Okay, so I hope you got the concept in a very specified manner, and also if you have any questions, any doubts, do let me know in the comments. Also, if you are watching this video for the first time, do watch my first and the second part of the video. Thank you for watching, and do like my video, subscribe my channel and share it with your friends. Thank you.